So now that we have a method to work with indeterminate forms, which is using the L'Hopital's rule, we're going to look at a number of scenarios which are not of that type, but they can be converted to that type. The first such example is indeterminate product. So first of all, let's see when we have product of two things, what constitutes being indeterminate. A few possible things that can happen is constant times something going to zero. That's clearly zero. Constant times something going to infinity is clearly infinity. But what about something that's going to zero multiplied by something going to infinity? Well, the last case is an indeterminate product. Because if you multiply a small thing with a large thing, you could get infinity, you could get zero. It depends on how small the small thing is and how big the big thing is. So we use a little algebra trick in order to solve this kind of problem. First, let's look at numbers, a concrete example. 24 is 4 times 6. I can rewrite that as 4 divided by 1 over 6, which is 4 over 1/6. Now this may look strange, but it's the motivation behind what we are trying to do. Similarly, if I have product of two things, f and g, I can rewrite it as f divided by 1 over g or g divided by 1 over f. Now the question is, why this strange choice? Remember that if f goes to 0, then the reciprocal goes to infinity. And if f goes to infinity, then the reciprocal goes to 0. That's the motivation. So if we have f times g such that one of them goes to 0 and the other goes to infinity, rewriting it as f over 1 over g makes it 0 over 0. And rewriting it as g over 1 over f makes it infinity over infinity. And then these are indeterminate forms, which we are already familiar with and we can solve with the L'Hopital's rule. And that's the whole point. So here's an example, x times ln x. As x goes to 0, the first term goes to infinity, the second one goes to negative infinity. As a concept check, you can try to recall the graph of log x and see what happens as x goes to 0 from the positive side. So I pick my 1 over x to be my denominator, and then suddenly I have a infinity over infinity term, and I can take derivatives. So I end up with 1 over x over negative 1 over x squared, which becomes limit x going to 0 of negative x, which becomes a 0. So we can, here's some more example. So in this case, the derivatives are more complicated, but it should also work. But what it shows us is that you have a freedom to choose between rewriting it as f over 1 over g, g over 1 over f, and you would want to choose the one that has simpler derivatives. X times sine of pi over x. Now this is indeterminate because as x becomes large, pi over x becomes small, and sine of 0 is 0. And you can verify this answer, you should get pi. Okay. And again, in this case, I'm choosing the 1 over x. I'm choosing the x to be written as a reciprocal. One of the motivations to do that is I have a pi over x here. So I know that somewhere in the chain rule, I'm going to have a negative 1 over x squared, which can be cancelled with the negative 1 over x squared in the denominator. Here's another example. And then we have something called indeterminate differences, which we are going to talk about in the next video.